Nature is filled with blueprints hidden in plain sight. These designs are so perfect, so impossibly efficient, that our best technology is, frankly, still playing catch-up. And one of its most brilliant secrets isn't locked away in some high-tech lab. It's in something you've probably held in your hand 100 times.
So let's just get right to it. The question at the heart of all this is almost hard to believe. How can a simple 2-inch maple seed, this little thing, have an aerodynamic efficiency that rivals, and in some ways actually surpasses, a multi-ton, 300-foot-long wind turbine blade?
The answer isn't just about gliding. It's about a hidden force, a trick of physics that plants mastered long before humans ever even dreamed of flying. And we are about to uncover that very secret.
Okay, so to understand this, we need to start with something we've all seen, but maybe never really looked at. The seed's almost magical descent.
You know the one I'm talking about. That slow, hypnotic spiral down to the ground. It looks gentle, almost lazy, a perfect little natural helicopter. We've called it gliding our whole lives, but that one little word doesn't even begin to tell the real story of the genius at play here.
Here's what most people don't realize. That seed isn't just passively falling through the air. It is actively flying. The technical term for it is autorotation. It cleverly uses the energy from its own fall to generate lift, which slows it down so it can travel way farther from the parent tree. It is, for all intents and purposes, a perfect single-bladed helicopter that needs no engine at all.
But here's where things get really interesting. For centuries, how it flew so well remained a total mystery. It took modern science and some seriously high-speed cameras to finally see the invisible engine that powers this tiny marvel.
For hundreds of years, the assumption was, oh, it's just air resistance. But then, as recently as 2009, two researchers, David Lintink and Michael Dickinson, finally uncovered the truth. And what they found was completely unexpected. It was a feature that basically challenged a fundamental rule of aerodynamics.
So get this, an airplane wing is designed to avoid stalling at all costs. A stall is bad, right? It's when the wing tilts too steeply, the airflow separates, and you lose all your lift. But the maple seed, it wants to stall. It intentionally creates a stall to generate an absolutely incredible amount of lift.
The mechanism that makes this possible is called a leading edge vortex, or LEV. Now, I want you to picture a tiny, stable, horizontal tornado that's literally clinging to the front edge of the seed as it spins. It's this beautifully controlled little pocket of chaos that generates all the power.
Here's how it works. As the seed starts spinning, that vortex forms, and basic physics tells us that rapidly spinning air creates a really powerful zone of low pressure right above the wing. That low pressure acts like a vacuum, literally sucking the seed upward. This elegant little trick doubles the amount of lift it can generate, slowing its fall way down.
And this is where it gets kind of beautiful. It's a perfect example of something in biology called convergent evolution. The maple tree, with no brain or muscles, developed the exact same high-lift flight mechanism that evolved totally independently in some of nature's best flyers. Hummingbirds, bats, and insects. They all arrived at the very same perfect solution.
So this amazing natural wonder isn't just a biological curiosity. It actually holds the key to solving a major problem in one of our most important pieces of technology, wind power.
On one side, you have this tiny seed, a self-contained marvel of passive engineering. On the other, you have a massive 300-foot wind turbine, the pinnacle of human engineering. And that huge turbine has a fundamental problem, a wall it just can't seem to break through. That wall has a name. It's called the Betz limit. It's a law of physics, figured out over 100 years ago, and it says that no wind turbine, I don't care how perfectly you design it, can ever capture more than 59.3% of the kinetic energy in the wind. That's it. It's the theoretical ceiling, the absolute maximum possible.
Our best turbines? They top out around 48% efficiency, which is amazing engineering, but still pretty far from the limit. But then, a study calculated the power coefficient for a falling maple seed, and the result? Well, this detail changes everything. They found its efficiency is 59%. Just let that sink in. This little seed is operating right at the absolute edge of what is physically possible.
So, what do you do when you discover that a simple seed is out-engineering your most advanced technology? Well, you do what smart engineers have always done. You steal the blueprint.
This quote just nails the shift in thinking perfectly.
For decades, turbine design was based on aircraft wings, long, thin, designed for smooth airflow. But the maple seed showed us there was a completely different, and in some ways, a much better approach.
Here's the specific problem that the seed helps solve. Right at the very center of a wind turbine, at the hub, the blades are moving really slowly. This creates what engineers call a dead zone of turbulent, messy air that generates almost no power. It's just a huge waste of potential energy.
The solution? Well, engineers developed this, the power cone. It's a device that bolts right onto the turbine's hub, and its curved, twisted shape is directly inspired by the weighted central part of the maple seed. It just smooths out that messy air and directs it over the blades much more effectively.
And the result of this little addition? By adding this simple seed-inspired cone, engineers can increase a turbine's annual energy production by up to 13%. That is a massive gain, all from copying a design that's been falling from trees for millions of years.
This story is about so much more than just seeds and turbines. It's a perfect example of a fast-growing field that sees nature not just as something to preserve, but as a mentor.
That field is called biomimicry. It's an approach to innovation that asks a really simple question. How would nature solve this? From designing more efficient ship hulls based on shark skin to this, learning about aerodynamics from a seed. We're finally realizing that nature is the world's largest research and development lab, with 3.8 billion years of successful prototypes just sitting there.
It really makes you wonder. The solution to one of our biggest energy challenges was just spinning its way down to the sidewalk this whole time. So, the question we should probably all be asking is, what other world-changing blueprints are out there, just waiting for us to finally pay attention?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.